Hello guys, so today we will learn about functions, the importance of them, and how to write them in Python. So let's dive straight into this. Why are functions important? So the first thing that we want to look into function is to reduce redundancy. What that means is basically if you have a repeated code over and over again, we don't want to keep copying and pasting it. So for example, let's say if you want to calculate an average of a list. So let's define, one first list. Okay, so 1, 2, 3, 4, 5. So now we want to calculate an average of this list, right? So we're gonna have to write the code for it. One way could be average. My list is, let's sum up the list. So if we use my list and divide by the number of elements within that list. So this will give us the average. So if you run this, oopsie, I'm not printing it out. Let me print it out. So average is average. So there you go. So we got the average of 3. Now let's say I have another list, okay? So my list 2, that is, let's say 5 and 5. Or let's just say 5 and 10. 5 and 5, okay? So now let's calculate the average for that. Again, we're going to need to do the same thing. Get the sum of this new list, okay? Sum of my list 2 divided by the length of this list. And let's print it out. Print average of second list is a average 2. Okay, we're going to do this. Or we can use the same variable. So that's how we're getting that average of the list. We can already see what's the problem here. We have repeated code. So this is a repeated code. This is the exact same code as line number 6 we have. What if we had, hundreds of lists? We want to calculate averages of hundreds of lists or thousands of lists. We're going to have a lot of repeated code that's doing the exact same thing. So one way we could do it is create a function. So in Python, the way you do it is you do def. So we're defining a function here. We can call it, let's say, calculate average. Okay, calculate average. That takes in a parameter. So what's a parameter is going to take in is a list. So it's going to take in, let's say, my list. And this will calculate the average of a list. So we can copy and paste this. All right, now sum. And this is not the way you do it in Python. This is a naming convention in Python. I'm so used to Java, so I do it in Java mainly. So now we can replace this repeated code. Okay, so we can remove this. We can call our function directly. So the way we do that is just call calculate average and pass in the list. And we can save this into a variable. Let's say, my average 1. Average 1 is this. We can do the same thing. We can replace this. Average 2, we can call this. And we can call our function calculate average, which takes in list number 2. So now if we're going to run this, we should get the exact same output. So pretty straightforward, simple. This is reducing our code. Okay, so that's one of the first key points of functions on how important they are. So the second point I want to dive into is encapsulation. Encapsulation is basically when we want to wrap our data or when we want to hide our data into like a single unit or a single class. And you can think of it basically, let's say you take your vitamins, right? In a vitamin, you take this capsule. Now, in that capsule, you may have lots of vitamin D, C, E, all these other vitamins. You don't know what all these contents are within that capsule. So that's what encapsulation really is. And it's one of the core fundamental concepts within object-oriented programming. Now, I'm going to have a separate video dedicated to object-oriented programming. But for now, we can see how functions work and the importance of it. One of the best example is this sum function. So sum is a built-in function within Python where it calculates the sum within a list. So let's do something very similar to sum where we're going to calculate the average. So to do that, we're going to create our custom class in Python. Let's call it average. And we're going to call our class average. Let's define the constructor for it. And this will be an empty constructor. Okay. Now within this class average, we're going to have our method called calculate average. And I spelled it terribly wrong. I'm just going to copy this from here. And this will take in a list, okay? And we can copy the exact code from here, which will return a list. So this is our function that we created, which calculates the average within our class called average. Now let's use this, okay? So I'm going to delete this. We're going to create our class, instantiate our class. Let's call it average is equal to average. So over here, we're instantiating our class. Let's import this. To access that method, we're going to use this object that we created, and we do a dot. So we got our calculate average, which takes in a list. Let's do the same thing here. Average dot. Now let's run this. There we go. So you can see now, we don't know what this method does, this calculate average. We have no idea what this method does. Well, we do. We know it calculates average, but we don't know the code of it, the inner workings of this function. We just know we want to, just calculate the average of a list and just give us the output. That's all we care about. So this is another example of importance of functions and how it works. Let's create another function, okay? Let's say, what if you want to calculate the median of this list? All right, so let's do that. So we're going to go back to our average class. We're going to define a method called getMedian. Now we can also use, I believe in Python, there's this statistics library or package we could use that has all these methods, getting the median, mode, and mean of a list. But over here, we're going to create our own. All right. So again, this will take in our custom list. And so the first step we're going to do is we want to sort the list. All right. We're going to tell it, okay, sort the list first. All right. So the reason we're not seeing any of that is we're going to tell it, okay, this takes in a type list. All right. We're forcing it. So first we will sort the list. Second is we want to get the median. We want to get the middle index for that list. All right. So we can get the length of this list. And we want to get the middle. What this symbol donates to is integer division. We want to do integer division. If we do divide by 2, so what's this? It's going to return us a decimal or floating number. So for example, if you do 5 divided by 2, that will return us 2.5. But we only want 2. All right, we want the integer value. So we do this double division, which is integer division in Python. We're going to have 2 cases. We're going to have a case of even and an odd. If the list is odd, we can directly return the middle of the list. But if it's even, we need to add up the 2 middle numbers and get the average. So let's do the first one, the easy one, where if it's odd. So to do that, we're going to first get the length of the list, all right, and then mod it by 2. So this is seeing if it's divisible by 2 or not. And if there's a remainder left, we're checking if there's a remainder left, then it's odd. And if it's odd, just return the middle of the list. All right. So that's the first case. The second case, else, we need to add up the 2 numbers, 2 middle numbers. Now let's do that. So my list mid minus 1 plus my list mid. I'm going to explain this shortly. Divide by 2. All right. This is how it's working. So let's say we have our list, which is even. We have 1, 2, 3, and 4. All right. We have 4 elements within our list. So first we're going to get the middle. All right. So mid is 4 divided by 2. it's going to return us 2. Now remember, I mentioned before that arrays or lists are index base 0. So this is returning us the index 2. All right. So if you go to index 2, so this is index 0, this is 1, and this is 2. So this is 3 we got. We're handling this part here, all right? We need to get this number as well, the second middle number, or the first middle number, which is what we're doing here, mid minus 1. So mid minus 1 will return us index 1, which is 0 and 1, 2. So that's pretty much what we're doing there. Let's test this out. So let's go to our main. Let's say we want to get the median of the first list. Median is average dot get median my list. We probably shouldn't have named it average. We should have called it something else, but just for testing. Okay, so let's copy paste this here. Let's test the second list out as well, and let's run this. There you go. So let's check the first list. Median is 3. 1, 2, 3. Yep, 3 is the middle number there. This is odd, and they're both the same as well, so it's going to be 5. Let's test another list out, which is unsorted. Okay, let's create my list 3, which has maybe 1, 4, 3, 2. All right, let's do 2. And let's print out the average. So the average is going to be, when this list gets sorted, all right, it's going to be 1, 2, 3, 4. So it's going to be 2 plus 3, 5. 5 divided by 2, 2.5. So we should get 2.5 as a median. Let's print this out. Average median is average dot get median my list 3. All right, let's run this out. Median is 2.5. There you go for this list. So you can see, the importance of function. We don't know how this code works, the get median. We just know we want to calculate the median of a list. That's all we care about. So we're hiding all the details within that function. And also, we're reducing the redundancy. We're not copying and pasting that same logic for list number 3, 2, and 1. We're directly calling this function. So we get a really nice, clean, easy to read code. So hopefully you guys got a much better understanding of functions in Python. We went over how to write functions, why functions are important. They help reduce redundant code, helps with encapsulation. And I'm also going to have a very similar video like this for Java as well. So if you guys are interested in learning how to write functions in Java, you guys can check that out. Take care and see you guys in the next video.